Hello and welcome back to the channel. In today's video, we will continue our discussion about game rules and mechanics. If you have been following along in the book, this is covered in details in chapter 4. In the previous episode, we created our first level, and the point of that video was to start incorporating and implementing some of the game mechanics that we have been talking about. The objective was for the user to be able to collect and to sort specific items in that level. In today's video, we will create another mini game to demonstrate further game mechanics, and the user's objective is going to be to complete a set of particular tasks that are going to be assigned at runtime in a given time frame. So we'll also take a look at how to create and how easy it is to create animations, state machines, and implementing some sort of a timer into our gameplay. So let's go ahead and get started. And today, before we dive into the Unity editor, what I want to go over is the section in chapter 4 inside the book where we are going to try to incorporate some of the concepts that we are going to be covering in the video. So we will be trying to create a level design, and that level is going to have 3 rooms, and it's going to have some sort of a randomizer. And basically, the player needs to go to the randomizer, and the randomizer is going to assign it a specific room and a specific color where the user needs to identify. So let's go ahead and click on play to see how it works. So here we have our player from our previous video that we created, and this is the randomizer over there. And currently, notice that those knobs that we have on the cube are white, representing that it hasn't assigned anything to the player. And we have our 3 rooms. Each room has a light fixture inside of it, and those light fixtures are basically the color properties. So let's go ahead and get to the randomizer. Now this turned red. It means that we have to go. Oh, there we go. Since we were talking, we ran out of time, and sorry, you lost. So let's go ahead and rerun this. All right, so I gotta quickly go to the randomizer. The randomizer is going to randomly assign a room to us based on color. So now we have to find that particular room with the color. He entered the room. That completes the objective. We got to run back to the randomizer. Now it's going to give us the red room. We got to quickly go to the red room, enter. Oops, we got stuck. No, we can run out. And we go back to the randomizer and we lost again. Sorry, you lost. So, all right. I mean, that is kind of the whole objective of this particular video, how to put together a game, a mini game in this case, for the player to be able to get tasks assigned randomly and then being able to achieve those particular tasks. So let's take a look at how we construct the rooms themselves. So I'm going to go ahead and double click on the room object, and let's dissect to see how this has been put together. So I have an empty game object, which has a bunch of components attached to it. In this case, we have the room controller, which manages the logic as far as how to open the door, what type of light we want to associate, or what kind of color we want to associate with the light, and etc. And then we have an animator, which basically is responsible of animating the closing and the opening of the door. And then we have the collider, which in this particular case we are using to trigger if the user has basically, entered within the range of the room where the door is going to open up. So below it, nothing fancy. We just have a definition of our three walls over here. Those are just basic cubes scaled and positioned in the specific arrangement. Then we have the actual roof, and then we have the door component over here. Again, all of these things are basic primitive cubes shaped in a way that we can arrange them. And then we have a point light. So let's go ahead and disable the door object. Then we have a point light placed inside the center of the room. And by default, the color is white on all of them, and the color will be assigned at runtime based on the configuration that's being done at the controller level. So each room, for example, this is the room ID 0, and the light color when we click on run is going to be assigned the right color. So this is the construct as far as how the room's structure is put together. Now let's take a look at the source code behind it. So let's take a look at the room controller. I'm going to double click here. So here we have our room controller script. Again, we have a few public variables for specific data points that is of interest for us. The first one is an ID. We want to identify our room with a specific ID. We want to know if the door is open or closed. And then we have a reference to the transform of the door. And we have a reference to the transform of the light. And then, of course, we have a public color property, which is used to set the light's color at runtime. And then we have a reference to our animator. And the animator is basically the state machine, which is going to control how the door is going to be behaving as far as opening or closing. So in the start method, we are referencing the animator. So that way we have a reference to it. And then we are setting the color to whatever color that has been defined at design time. We have the onTrigger enter function defined. We have seen this in the previous video too, but let's go ahead and cover it again, just in case if you need to get a revision on this. So we are checking to see who has entered our collider as a trigger. And if whoever has entered into our collider happens to be the player, what we want to do is check to see, in this particular case, if the room ID that has been assigned to the player, and that's handled by the player room controller, equals to the same ID as this particular room, then we are going to go ahead and open the door for the user. Otherwise, we are not going to do anything. And if it happens to be that the room ID that's assigned to the player happens to be the same as the room ID that the player has visited, then of course we do the door open, which we call a specific function here, open door. We pass in the value. And what we are doing is that we are talking to the animator. And inside the animator, there's a property called open. And we are setting it's a Boolean property. We are setting the value of that Boolean property to either open, like true or false. And we'll look at the animator and see how that's constructed as well. And then finally, what we are doing is that through the player controller, the player room controller, we want to also indicate if that particular room has been visited by the user or not. So there's a data structure in the player controller room, which we can take a look at next. And in that particular data structure, we basically keep track of which rooms have been visited by the user and etc. So let's go ahead and jump into that right now. So right click here and say go to definition. And in the player room controller, we have an room data class, which is basically just like a data container. We have an ID property and we have a Boolean visited property. And basically what we are doing in the player room controller, we have a collection of rooms. This will be defined at runtime. And basically we have a timer. In this case, we are giving the player like 33 seconds to be able to perform all of these tasks that are going to be assigned to them. And we have another Boolean flag that is going to indicate whether the player can keep on playing or not. In the update function, the timer basically is going to be checked to see if it's greater than 0. And if it is greater than 0, then we want to subtract the timer. It's kind of like a countdown. And if the time reaches 0, then basically we disable the keep playing flag. So basically the game is over. And the last thing that we are doing in the update function, if it's still keep playing, we want to display the actual time, and then we pass in the remaining time variable. So the check objective is being called, and inside the check objectives, have a we iterate over the rooms that we have defined already, and we want to see if all of them have been visited or not. And if they have been visited, we have a counter. If the counter happens to be 3, in this particular case, we have 3 rooms, then we want to end the game. But the state of the game is that you made it, meaning that you won. So you actually beat the timer and you achieved all of your objectives. If the timer goes below 0, or if the timer is 0, then basically we stop the game. And if you have not met your objectives, then basically we are displaying, sorry, you lost on the console. Eventually, all of this data you want to incorporate it in the UI. Then we have the room selector controller. This is that spinning cube that basically will assign your next objective, right? So basically what we have is that in the update, we just keep on rotating the object on the Y axis 1 degree. And basically we have another on trigger enter event here. Basically when the player goes up to that spinning cube, what it does is that it randomly arranges which room is going to be assigned to the user. And then basically it assigns the room to the user. And then it updates the color visually to also indicate which room they should go as well as a visual feedback. So let's go back to the editor. And this time we'll move faster. So notice that all the lights are white in design time. And as soon as we go to runtime, all of them have been changed to their respective colors. Let's quickly go to the randomizer. Go back. Go back. Great. All right. So it looks like we lost. We missed it. Notice here the collider actually comes out to just a little bit. We lost this game by just a millisecond, probably. So you can actually visualize the collider. This is the collider that will get triggered on the room controller script whenever the player enters it. And it looks like we missed it again by just milliseconds over here. So we didn't make our objective. Now let's take a look at the animator. So in the animator is basically in a state machine. So double clicking that, I have gone ahead and created two basic animations. One of them, it's actually one animation. So I created one animation and I inverted the animation uh, to simulate the closed door behavior. So we have an open door and I inverted the speed of the animation and that reverses the playback. So we have an idle and door open animation. If you double click on the actual animations over here, you would notice that we have the two keyframes over here, because again, this is pretty simple. You can do very complicated different types of animations, and you can have some really cool stuff going on. But basically for this basic uh, demonstration, we just need to make sure to, on the first keyframe, basically the door is closed. And then on the last keyframe, the door is going to be open. So the Y axis is going to differ between the two. So this was the idle one. So there is no difference between the Y axis on either one of the keyframes. But if I open up the door open, and if you go to the first keyframe, the initial position on the Y is 1.006, and then the final position of the Y is going to be negative 0.926. And this basically will simulate that motion that you see when the door opens. When you create an animation on a particular object, it would automatically attach the animator to the associated game object that you're trying to animate. And in this case, we created the animator called root room. And once you have created this, you can drag and drop those animations into the state machine simply by dragging and dropping them over here. And then you can create your transitions between one state to the next state. I'm gonna have a separate video covering state machines and animations in more detail because there's a lot to cover. I don't want to overdo it in this particular video, but just for the sake of it, what we are doing is that we are having an idle state defined by the idle animation, and then depending on the trigger, that parameter that's being passed, so the parameter can be defined. There's only a few parameters that you can define. So you have a float type, int type, boolean type, and a trigger. So on the animator, we have different layers. You can have multiple layers too, depending on the complexity of your state machine and the kind of blend animations that you want to do. And then we have the parameters where this is how you would send and receive data from C# into the state machine. So we have an open parameter, it's a Boolean type, and that's basically what's being called over here, right? So we are setting a Boolean value to the parameter, and then you have to hardcode this hardcode the name of the parameter. There's no other way to do it. So let's take a look at how the state machine behaves once we get into the runtime. So notice I have nothing assigned to the player. So if I go to any one of these rooms, nothing's going to happen because no ID has been assigned to the player, right? So it checks to see if the ID that the player has, the objective that has been assigned to the player, is the same as the room ID that you're visiting. So let's go ahead and check this. As soon as we get, oops, we lost. So let's redo it now. So as soon as now we get to this transition got triggered based on the condition. The condition happens to be the open parameter needs to be set to true. If that's the case, we transition into the new state. And if we move out, we transition into another state, in this case, the closing of the door. And that happens when open is set to false. The open parameter is set to false. All right, so I think there's quite a bit here. Of course, the implementation I have done in this video is a little different than what is being covered in the book. This way you can get to different perspectives. The implementation in the video utilizes state machines and animations. The implementation in the book is all code-based. So you utilize linear interpolation and transform translate to basically open and close the door. And in this video, we are using state machines and animators to do the same thing. All right, so hopefully this was enjoyable, and see you guys in the next one. We'll create like a mini RTS game. Have a good one. Bye-bye.